All right, so today we're doing more of what we did on Tuesday. So the same square root method. So we're going to go through a problem like problem number 1 here to refresh our brains. We're using the square root method. Our goal is to isolate whatever is being squared so that then we can take a square root, okay? So what do we need to get rid of? The 1/2. How do we get rid of the 1/2? By the reciprocal. Very good. So we're going to multiply both sides by 2/1. That's going to get rid of our fraction for us, which is nice. And so I have then x plus 1 quantity squared equals 40 times 2 is 80. And now, since we've isolated whatever's being squared, now I can do something very sneaky to get rid of that power of 2. How do we get rid of the power of 2? Square root both sides. So the square root and the square undo one another. They're inverse operations. And what do we need to remember when we take a square root? Plus or minus. That's the huge thing. There's always got to be a plus or minus whenever we take a square root. Now, 80 is a magic number. I wanted to make sure you all knew that 80 is 16 times 5. There's that magic 16 in there, which is a really good one to know. So because of that, we can simplify our radical. What is the square root of 16? 4. And then that 5, we can't take the square root of, so it stays under the radical. And then, of course, there's still that plus or minus out in front. And on the left-hand side, we just have our x plus 1. How do we get x by itself? Subtract the 1. So we're going to subtract that little 1 just to move it over. We're going to insert it right next to the equal sign. So -1 plus or minus 4 radical 5. And can we put the -1 and 4 together to make it a 3? No, we cannot. Again, this 4 radical 5 is a totally radical number. He's very cool. Too cool for this guy. All right, so they don't mix. All right. There are 2 answers for x here. What are the 2 solutions for x? -1 plus the 4 radical 5, and then -1 minus the 4 radical 5. And that's really important that you understand how to take those apart because we might want to approximate those and get decimals using our calculators if we wanted to. All right, so that's what we're going to be doing again, except we have this new added element today. Here's the added element. On Tuesday, I asked you this same sort of question. I asked you what number squared gives us positive 25, but this time I want to say, hey, what number squared gives us negative 25? What's your guess right off the bat?
Well, it can't be -5 because you multiply it just to a positive.
Right, so if we tried -5 and squared that, that'd be -5 times -5, and that's going to give us that positive 25. That's not what we want. And they're like, oh, well, then let's try 5. Well, 5 squared is 5 times 5, and again, that gives us positive 25. So is there a number that we can square that's going to give us a negative result? No, there is no real number that's going to give us a negative result when we square it. Because there's no real number, we had to create something. And we had to create something so that we could solve this in theory land. Okay, this algebra theory, this isn't real world algebra. We had to create this imaginary number I. So we call I an imaginary unit. And that imaginary unit turns out to be the square root of -1. And what that is going to do is it's going to allow us to actually figure out a number that we can square that will give us -25. Okay? And so we now can solve problems where we have we're equal to a negative value. And I'm going to show you how to simplify that today. So we're going to be trading the square root of -1. If we see that today, it's equivalent to an I. So if you see a square root of -1, we can replace it with an I. And that is I for imaginary because it literally is imaginary. It doesn't exist in our real world. It's our little imaginary friend. Okay? And this is what math does. We just create stuff so that we can then solve a newer problem. All right? That's how math evolves. Kind of interesting. All right. So, example 1, solve the equation. Example 1, solve the equation. And remember, we can trade now. Anytime we see the square root of -1, it's going to be replaced with an I. All right, so I have x squared equals -9. We're still using the square root method we used from Tuesday, and our goal is always to isolate whatever is being squared. Whatever has the power of 2 on it, we want to isolate it. So we're isolated already, right? Okay, so I don't need to do any work. But how do I get rid of our power of 2? Square root, we're going to square root both sides. Don't forget the plus or minus. And so the square root and the square cancel out, leaving just the x there. And we have a big plus or minus in front. And I want to look, and I can think about this whole square root of -9. I can think about it as a -1 times 9. The reason I want to do that is because then I can see, well, look, I have the square root of -1. What is the square root of -1 equal to? I. Yeah, the square root of -1 is equal to I. So that comes out as an I. And what's the square root of 9? 3. So I'm going to put the 3 next to the I. And so this is our answer, plus or minus 3I. So anytime now we see that negative under the radical, it gets to come out as an I. All right. There are 2 answers here. What are our 2 answers for x? Positive 3I and negative 3I. All right. And so these are 2 answers, and these are 2 imaginary solutions. Meaning it ain't real, but imaginary, all right? Imaginary solutions always come in pairs. You're always going to have plus or minus, okay? Because of taking the square root, we have to have the plus or minus. So 2 imaginary solutions, and they're always going to come in pairs. All right, let's look at letter B. 2x squared plus 3 equals -13. Again, our job is to isolate whatever is being squared. What should we do first? We will eventually. We will divide the 2 eventually. What should we do before we do that? Yeah, subtract 3. Any adding or subtracting, that's what we want to get rid of first. So I'm going to subtract 3 from both sides. So I have a 2x squared on the left. And on the right, I have a -13 and a -3. What's that? -16. Very good. Now again, I need to get x squared by itself. What should I get rid of? The 2. How do we get rid of the 2? Divide. It's 2 times x squared, so we're going to divide both sides by 2. So I have x squared equals, what do we get on the right? -8. Very good. And now we can get rid of our power. How do I get rid of the squared? Square root. Don't forget the plus or minus. Square root and square cancel out. And so I'm left with x equals plus or minus And this whole square root of negative 8, I can take apart a little bit. There's a negative 1. And then 8 has a perfect square in it. What perfect square does it have? 4. 8 is 4 times 2. So there's my perfect square I want to look for. What is the square root of negative 1? I. What's the square root of 4? 2. And then I can't do anything with this 2. He stays under the radical. He's not a perfect square. So we say plus or minus 2i radical 2 is a great answer. It doesn't technically matter what order you simplify this in. So if you had an I first, and then the square root of 4 was 2, and then that's going to stay radical 2, that's an acceptable answer as well. Everything is being multiplied. I could do radical 2 first, times I times 2. That's also okay. This is how I'm going to write it traditionally. Okay, this is just pretty much how you'll see it. All right, a couple more, a few more, 3 more. We're going to do more of this tomorrow. I want you to be super good at it. 2x squared plus 26 equals negative 10. What do we want to do first?
Subtract 26.
Subtract 26. Do any adding or subtracting. First, we have 2x squared equals negative 10 and negative 26 is negative 36. And then we need to do what? Divide by 2. Divide by 2. So we get x squared equals 36 divided by 2 is 18 with a negative, negative 18. And now, how do we get the squared off? Square root, both sides. Don't forget plus or minus. Square root and square undo one another, leaving the x all by itself. We have a plus or minus in front. And I need to think about this. Here we have that negative 1 right there. What's the square root of negative 1? I. And then 18 breaks apart. What perfect square is inside 18? 9 times 2. So we can take, what's the square root of 9? 3. So I'm going to put that in front of the I. And then radical 2 stays under the radical. So plus or minus 3i radical 2. So anytime you see the negative under the radical, you can just pop out an I. Sort of the simple way to take care of it. All right, we have negative 1/2 times the quantity x plus 1 squared plus 1 equals 5. What do you want to do first? Subtract 1, good. So negative 1/2 times the quantity x plus 1 squared equals 5 minus 1 is 4. And now, again, I'm trying to isolate this thing that is being squared. So how do I get rid of this negative 1/2? Multiply by the reciprocal. What would I multiply by? Negative 2. Very good. Negative 2 over 1. How come I want to multiply by the negative? Yeah, the reciprocal includes the sign. But also, we want negative times negative. We want to get a positive thing over here. So, yes. So, negative 2 times negative 1 gives me a positive 2 over 2, which is 1 and cleans itself up just great. 4 times negative 2 is negative 8. How do we get rid of the squared? Square root both sides. Don't forget the plus or minus. How many times have I said that now?
A
A lot. Can you believe anyone would ever forget it? Half of you will. Half of you will. Half of you will get the problems wrong because when I test you, you can guarantee I'll put like positive 3i radical 2 as an answer. And then answer B would be plus or minus 3I radical 2. And then answer C would be negative 3I radical 2. Like, and everyone will put the A. Okay? I'm just warning you. All right. So we get x plus 1 is equal to plus or minus. What is the square root of negative I? And then 8 breaks apart into 4 times 2. We want the square root of 4 is 2. And then radical 2 stays under. Looking for those perfect squares. And then how do we get x by itself? Subtract the 1. So we get x equals, insert that negative 1 plus or minus 2I radical 2. We don't want to break this guy up. We can't. They're all connected by multiplication, a good magnetic bond. Okay, so here we go. Those are 2 answers there. Questions so far? All right. Uno más. X minus 1 quantity squared equals negative 7. What should I do?
Square root.
Square root. Yeah, I don't have anything multiplied on there. I don't have anything added or subtracted on there. So we can go ahead and square root right off the bat. Don't forget the plus or minus. Square root and square undo one another, leaving x minus 1 equals plus or minus. Square root of the negative 1 is I. And then 7. Are there any perfect squares in 7? No perfect squares. So he stays. He's a prime number. So he stays radical 7. I radical 7 is a great answer. And then what should I do with my 1? Here. Add it to the other side. Very good. So we get x equals 1 plus or minus I radical 7. And again, what are the 2 answers for x, the 2 solutions? Can you say it like?
X equals 1 plus I. So
Good. And then 1 minus I radical 7. Very good. I like it when you guys actually speak the words because I think it helps ingrain it in your brain a little bit. So. All right, ladies and gentlemen, thank you so much. Do you have any questions for me? All right. We have a good solid half hour here to get this assignment done. There's some interesting ones in there. Watch out for fractions. In fact, I'll just do one real fast. If you had like negative 1/25 equals x squared, and you went to take the square root of that, square root and square cancel out, so you get your x. And this giant square root, we get to break apart into 2 little square roots. So that'd be the square root of negative 1 over the square root of 25. What is the square root of negative 1? I. And the square root of 25? 5. And don't forget the plus or minus. So plus or minus I over 5. Okay? So you'll see a couple like that in your homework. Please make sure you put your seat number on your homework.